Good morning and welcome to lesson 7.1. We are going to build on our understanding of trig functions and we are going to work on not right triangles. So an oblique triangle does not have a right angle inside of it. So you can see these ones that I have here do not have right angles. These are just showing the angle that we're referring to. So there's another law that we can use. It's called the law of sines. And that law helps us to be able to find other lengths and other angles of the triangle. Okay, so we are going to start with the first. This law of sine says that these ratios of the side of A opposite the sine of the angle of A is equal to the ratio of the length of side B as a ratio to the sine of the angle of B, and that's equal to the ratio of the length side of C, which is a ratio to the sine of the angle of C. And we can use these known truths about these ratios to help us find other sides. So one of the cases is called angle side angle, and this is just an example of a triangle where they've given us an angle and then the enclosed side and then another angle. So it has to be angle, the enclosed side, and then another angle. So we're going to look at number 10 in the book. I've drawn a picture of number 10, and they've given us the angle of 25, the angle of 105, and the enclosed side 7. And that side is actually equal to the length of A, side A. So what we're going to do is we're going to use the knowledge that because we know these two sides are 105 and 25, we can then find the angle of A. So angle A is going to be equal to 180 minus 105 and minus 25. So 180 minus 25 minus 105. So that angle is going to be angle A is equal to 50 degrees. So knowing that, we can then use what we know here. So we know A is 7 over the sine of 50, and that's going to be equal to the length of B over the sine of 105, and that will be equal to the length of C as a ratio of sine of 25. And then we can use our cross multiplication to find those. So to find B, we are going to multiply. We're going to use these two ratios. So we know this ratio here, 7 over sine of 50. And so if we multiply both sides by sine of 105, we can solve for B. So B is going to be equal to the sine of 105 times 7 over the sine of 50. Excuse me. And then that needs to be in degree mode. And then we're going to do sine, and we'll be able to see the sine of 105 times 7 divided by the sine of 50 comes out to be 8.8265. 8.8265. We can do the same for C. Side C is going to be equal by multiplying the sine of 25. So the sine of 25 times that same ratio, 7 over the sine of 50. And so actually I can just go up and copy, go up and highlight that row. And the only thing we're going to change is now we're going to be the sine of 25 times that other ratio. And so the length of side C comes out to be 3.8618. Okay. So next I would like to look up number 14. So number 14 says solve the triangle. Solve the given triangle. Right here it is. Solve the given triangle. Standard notation is used for labeling triangles. Round out answers to 4 decimal places. So we're going to do number 14 here. So they gave us an angle and a side. And we're going to, I labeled those here so that we could see that we have an angle and a side and an angle. So it works similar to what we had before. So we can find angle A by taking 180 and subtracting 120 and subtracting 35. And we get 25 as our angle A. So we know our ratios, we can set those up. Our ratios are going to be 12 over the sine of 25 is equal to B over the sine of 120 equals C over the sine of 35. Just like we did in problem number 10, we can multiply to solve for B. We can multiply our A ratio times the sine of 20. You've probably heard of it before. It's called cross multiplying. So B is going to be equal to the sine of 120 times the ratio of 12 over the sine of 25. And so I'm just going to go up and copy this one and modify it because it's going to be 25 there. That's going to be 12. So I have to insert a 2. And then that's going to be the sine of 120. So I have to insert a 0. Okay. So you see here. Oops. Enter. Okay. So the length of B is 24.5903. And then C is going to be sine of 35 times that same ratio. And so I'm going to go ahead and copy that one. And I just have to change this to the sine of 35. Make sure you delete or insert where you need to. And so C is 16.2864. So it's pretty cool. If we have right triangles, we can use our regular properties of trig functions, but because this is an oblique triangle that does not have a right angle, we can use these law of sines. So this is there's 3 cases that we can use the law of sines, and this is the angle side angle, where we have an angle, an enclosed side, and then another angle. So 10 and 14 are for that case. Now we have another case where we can use the law of sines, and that is the angle side. So you can see here we have an angle, and a side to go with one of the angles. And it happens to be that this side 40 goes with the angle of 30 degrees. So I'd like to look at number 18. 18, when I drew the information that they gave us, you can see that they gave us side C to go along with angle of C, and then we also have the angle of B. I'm sorry, number 8, not number 18. So number 8. So we have the side 10 goes with angle C, and then we have angle B. So in that case, we can again find angle A by taking 180, subtracting 120, and subtracting 40. And that gives us 20 is angle A. And then we can set up our ratios. So we have side A over sine of 20 equals the length of B over the sine of 40 equal to the ratio of 10 over the sine of 120. So very similar to the other problems that we did, except for now, we are using C in the reference angle. C is our ratio. So this time we're going to find A by we're going to multiply the sine of 20 times 10 over the sine of 120. So again, I'm just going to copy these and set them up. So this is 10, and then this is 20. And we get 3.94. 3.9493. And then side B, we're going to do the same thing. So sine of 40 times that same ratio. So we can just go up and copy in our graphing calculator and modify. The only thing we have to modify is the sine of 40 right here. And we get 7.4222. Number 18, we are going to do. Number 18 is another instance where they just gave us the sides and angles, and we had to kind of put it together here. And we can see that they gave us this, again, C, an angle of C is 120. That's interesting. Make sure that I wrote that down correctly. And then the side angle A is 25. So we need to find angle B by taking 180, subtracting 120, subtracting 25. So on that one, angle B should be equal to, I believe, 35. And we can set up our ratios here. So and C, the length of C is, and you will notice, if you haven't already, the longest side always goes with the largest angle because it's more spread out, so it's going to make a longer side. And then the next longest side is going to be across from the next largest angle, which should be B, and then A should be the smallest side. So you can see up here that our largest angle was C and our longest side was 10. Our next largest angle was B, and B was almost double A, and the angle was double. Okay, so we can use our ratios again. So side A is going to be the sine of 25 times the ratio of 14 over sine of 120. And that is almost identical to what we had, so that's cool. We can just go change this to 14, and then sine of 25. So 6.83, 6.831. Let's round that to 20 because it actually should round up. That's A. And then B is not double, but it's a little bit bigger, so it should be a little bit longer. So sine of 35 times that same ratio. And this is going to be the sine of 35. And that gets me to a length of 9.2723. There we go. So we've done one scenario using this law of sines called the angle side angle. We've done the second scenario where we have angle angle side, or side angle angle, that depending on how you call it. So angle, angle, side, where this angle and this side actually go together, right? 40 and the angle of 30. And now we're going to look at the scenario of side-side angle, because we have two sides and an angle. So this puts us in a little conundrum, because there's possibilities here that mathematically will work that don't always work with the actual triangle. So that's why side-side angle can have three possibilities. It could have one solution, it could have two solutions, or it could have no solution. So let's take a minute and go to the book and look at the different scenarios that are in the book. So here we are in the book on page 559, and we're going to the case here where it starts talking about, just about in the middle on page 558, sorry, where it shows the three possible cases. Okay, so it's called the ambiguous case, because sometimes you can have a no solution triangle. Sometimes you can have a one solution triangle, and sometimes you can have two solution triangles where they gave you two sides and an angle. Okay, and only one angle. So we're going to look at first example 3 here has one solution. So they gave us the angle of 60 and the side opposite is 6. And then we have the side B length is 3. Okay, so we're going to draw what we think it could tentatively look like. And then we're going to use our ratios, the sine, using the sine, law of sines, the ratios here, and fill in what we know. And we find out that if we solve for B, then we're going to get 3 times the sine of 60 over 6. And notice that they're using the ratios of the law of sines, reciprocals of what I was using. And that's okay as long as you're using them similar to each other. Okay, so that means the sine of B equals 0.4330. And so we're going to use the inverse sine of B to do that. And make sure you're in degree mode. So if the angle of B is 25.66, we know down here on page 559 that that means the angle of, it says, if you take 180, subtract 25.66 for the angle of B, we get 154.34 degrees. That means that the first angle A plus 154 degrees would have to equal 214, but that's bigger than what's possible for the 180. So that's not going to work. Okay, so this is not possible because the sum of all three angles of the triangle must equal 180. Thus, the only solution for B is 25.66. So otherwise there could be another possible solution. But because B is 25.66, we can take 180, subtract the 60 we were given for the angle of A, subtract the 25.66 that we were solved for angle B, and we know that angle C must be 94.34 degrees. Okay, so to go back up and look at the other possibility, it says the other possibility for B is the obtuse angle whose sine is also 4.33. That would be the supplement. So 180 minus what we think B is, which would be 154.34. But that won't work, because if that's true, then A and B together would be 214, which is bigger than the total of 3 angles. And it says that those 2 angles would be more than that. So that's not going to work. So we know that there's only one solution. And so C is 94.34 degrees. And then you can go ahead and solve for the length of C, which we've done before using the sine, law of sines. Let's go to the 2 solution case for side-side angle. So let's say we have an angle of 40. The side opposing that is 8. And then they gave us a length of side 10. So this is what we're thinking our, where my mouse is, what we're thinking our tentative triangle could be, using the law of sines to find the angle of C, because we know the side C, we're going to multiply both sides by 10, and then the sine of C should be 0.8035, which means that the inverse of sine of that would be 53.47 degrees. So if that's the case, then we could find the other angle, the obtuse angle, that's bigger than, that is a supplement of 180, that would also give me that sine. So 180 minus 53.47 would be 126.53. And because we could, if we used 126.53 plus my original angle of A40, we're still under the 180. So there could be a third triangle that has a very small angle for C. Okay, so either C, so either C equals 53.47 or C equals the 126.53. So there could be two angles here. So if C is a 53.57, I'm going to show it my paper here. I'm going to show you this one because they don't really go through. Oops. I can share my book because that would be easier to show. So here are the two possibilities that we're speaking of right down here. So if it's this top left one, then we're going to have angle A is equal to 40. Then we propose the angle C was possibly this 53.47. That means that angle B would be 86.53. So those could all work. If it were this triangle here, so if it were angle A is 40 and angle C is the obtuse angle, so the supplement to this, which we said was the possibility of 126.53, then angle B would be the small angle of 13.47 here. See it, 13.47. So angle B would be 13.47. And that's what they show here. See how tiny angle B is. They didn't really work that out. Then the third situation, and as I will show you right from here, the third situation is on page 560 at the top. It says there's no solution. So let's look at this one. So we have I'm going to just draw this. So we're saying angle A is 75. I'm going to say this right here, angle A. And they gave us that side A is 10. And they're saying side B is 15. And then this is C. And the reason that I know side B is the longest is because they gave us two lengths. I don't know how long C is, but I know that B is longer than 10. So the angle of B must be bigger than 75. Okay, that's something we have to keep in mind. So if we use our law of sines ratios, we go to solve for sine B and say that sine B is 1.449. So because the sine of an angle cannot be greater than 1, there is no triangle that is equal to this. So we know that can't happen. So that's the situation where there's no solution because we can't get a sine that. So you could try to do that. You could try to do inverse sine of 1.449 in your calculator, and it would tell you that that's an error. So that's how you know that that triangle will not work out. Okay. So that being said, let's go to number 24 is one that I wanted to work out. So number 24, we have angle 25 degrees, side 7, and then a side 9 that's longer than 7. So that's how I know that that angle for angle B is going to be bigger than 25. And then it looks like C must be the biggest because that's what I have drawn the longest. So we'll see there. So let's write what we have. So for A, I have, I'm going to write my sine because I've been giving the angles of only one. I'm going to write that in the numerator this time. So the sine of 25 over 7 is equal to the length of B over the sine of, well, I don't want to do that. I want to write them the opposite. The sine of 25 over 7 equals the sine of B over 9. That's what I meant to do. So the sine of B is equal to 9 times the sine of 25 over 7. Is 0.5434. And actually in the graphic calculator, you can go ahead and just use that. So you can say the inverse sine of second, and the negative key gives you the answer. It'll use the previous answer. So it's going to use all of that, all those decimals. It gives you the angle that's a little bit more accurate. So 32.91 degrees. And so B, angle B is 32.91. Okay, so I want to see if there's more than one possibility here. So I'm going to look for the supplement of B. Is going to be 180 minus that. And that would be 147.09. And 147.09 plus the angle of A. So if angle B equals 147.09 and angle A is equal to 25, then we could have angle C. So 180 minus 147.09 minus 25. Angle C could be 7.91. Okay, so we have two triangles. So in the triangle, the first way we found B with this one, then angle C on that one is 180 minus the 25 of A minus the 32.91. Really sorry about that. Right in here, minus 25 minus 32.9. So C is going to be 122.09. Okay, and then the side of C C is going to be sine of 122.09 equal to the ratio of A, which is 7 over sine of 25. So C is going to equal sine of 122.09 times 7 over the sine of 25. So it's going to be times the 7 divided by the sine of, so 14.03 is what I get for the side of C there. So C is the largest angle, so its side is going to be that. And then the second triangle, so this is, there's going to be two triangles here on number 24. Two triangles that work. Okay. Then the second triangle, we have angles 147.09 for B, A is 25, and then C is 7.91. So C this time is going to be by taking the sine of the C angle, which is 7.91, and multiplying by 7, that ratio of A. So I can just go up and copy here and change this to angle 7.91 for C. And so C is going to be very short. It's only going to be 2.28. Should have a lot more paper for myself. Okay, let's look at number 26. So 26, this is a possibility that we have. We have angle A is 50 and side A is 10, and then side B is a little bit shorter at 8. And I don't know about C. So let's just set this up. So I'm going to do, because I'm trying to solve for a side or for an angle, I'm going to set it up like this. So the sine of A, so the sine of 50 over the length of A equals the sine of B over the length of B. So sine of B equals 8 times sine of 50 over 10. So that's going to be 8 times the sine of 50 divided by 10. 6128. So using the inverse sine of the answer gets me to 37.79. So that's for the first triangle. If there's two. So the first triangle would be angle C is going to equal 180 minus 50 for A and minus 37.79. So minus 50 minus 30.79. Oops. No, 180 minus 50 minus 50. Okay, 92.21. That's angle C. And then side C would be equal to, when we do the ratios, it's going to be the sine of the C angle, so the sine of 92.21 times the A ratio, that's the one we were given. So 10 over the sine of 50. So that would be the sine of 92.21 times 10 divided by the sine of 50. And so that means our length of C would be 13.044. Now, if there were a second triangle, so let's just write triangle 2 question mark. If there were a second one, then my complement of angle B, my supplement of angle B, I mean, it would be 180 minus 37.79 would be 142.21. Okay, and if that were true, if angle B equals 142.21, then angle C would be 180 minus 142.21 minus 50 that we were given for angle A, right? Because this is going to be angle B, angle A. So angle C, we can see it's going to turn out to be negative. 180 minus 142.21 minus 50 would be a negative 12.21. And so that's not feasible. So we know there's no second triangle. So there's only one triangle for 26. Okay. I'd like to look at 20. I had 28. I'd actually like to look at number 30. So number 30. That's a picture. Here's a picture kind of like this. And then it's not a right angle there. This is like 80 degrees. And they want us to find this H right here. We know this big angle up here is 92. And this side is 10. And this angle is 40. Okay. So to be able to use law of sines here, we need to find some others for some other information about this triangle. So I know using the supplement here, if that's 80, then this is going to be 130. Okay. And then I also know this little angle, we'll call this A. So we know side A is going to be, so angle A is going to be 180 minus 92. We'll call this side, we'll call that angle C, minus angle B, which is 40. So angle A is equal to 180. So angle A is equal to 48. 48. Okay. And so angle C can be broken up into two parts. So angle C should be 180 minus 80 minus 40. So this part should be 60. And this part should be 32. Let's make sure that this adds up to 180. 48, 32, and 130. Oops, 180, this should be 100. This 130, I misadded that, that should be 100. And if that's 48, then that would be 32. Yep, so that makes 80. So this is that. So to find this side, we have our three angles, 48, 132, but we don't know any lengths of those. So we need to find at least maybe the length of B. to do that. In either of these actually. So let's just do this length B here. Okay, so B is compared to sine of its angle 40 as A, which is 10, is equal to the sine of 48. Okay, so to find B, we can take the sine of 40 times the ratio of 10 over the sine of 48. And find sine of 40 times 10 divided by the sine of 48 is 8.65. Okay. So now we know that. So I'm going to just draw this angle. I'm just going to draw this triangle off down here by its right here. So that's 100. This is 32. This is B, which we now know is 8.65. And this is 48. That's A. Okay. So let's see. We want to know this H, which goes with C. So we have angle, side, angle, angle. Okay. So we know the length of H that we want over the sine of 32 will equal the 8.65 over the sine of 100. So H should equal sine of 32 times 8.65 with a sine of 100. Now, there are definitely other ways to get at this length of side H because there's other ratios that you could use, but this is just what I chose to use. Sine of 32 times 8.65 divided by the sine of 100. So I get 4.65, 4.7. So we did it. Yeah, there's definitely other ways you could get there. There's all my work for 30. There you go. See it all. Okay. I would like to do a couple of story problems with you. And the first one is number 34. And 50 are the last two that so 34 is distance. So it's this right here. It says the locations of point C on a small island off the mainland, points A and B. Off the mainland and points A and B on the shoreline. So C is in this island, and then A and B are on the mainland and the shoreline of. So if A is 63 degrees and B is 76, and A and B are 5 miles apart, find the shortest straight line distance from point C to the mainland. So we want point C to the mainland. So which one is going to be the shortest? So the shortest is going to be CB because it's the smallest angle of the two angles. So we're really trying to find this side A because that's going to be the shortest side because it's the shortest, the smallest angle. A is shortest side because angle A is smaller than angle B. Okay. So that means we can use angle C is going to be 180 minus 63 minus 76. So angle C is 41. Okay. So we know if we are trying to find A, so A is compared to sine of 63 compared to 5 and sine of 41. So A is sine of 63 and 5 and sine of 41. So sine of 63 times 5 divided by sine of 41. So it looks like the shortest distance is 6.79 miles. Let's go ahead and just make sure, because that means that B would be over here. B would be over the sine of 76. So let's look at what B. I'm just going to copy that. And B would be the sine of 76. So that would be long. I have that one to be longer. At 7.39. So the shortest distance would be B to C. So as I reread the problem, the straight line distance was not making sense to me. So these were the 2 points on the mainland, but they wanted straight line distance. So the shortest distance is between any 2 points is a straight line. So it's going to be shorter to go directly to the mainland right here, which would create a right triangle. So we found side A here. to be 6.79. And we also found 7b to be 7.39. So to find this side opposite any of the angles, we can use the sine. So because I've created a right triangle now, so we can use the sine of 63 will equal the opposite. So that would be our, let's call it H. That's what we want. That's our straight line distance over that hypotenuse, which would be the 7.39. So 7.39 times the sine of 63 should give us H. Okay, yep, and that's the shortest distance. So H is only 6.58 miles. So a little bit shorter than A, 6.58, the straight line distance. Make sure you pay attention to that. Okay, the last problem that I want to do is number 50 on page 566. Right here. I drew a picture, but I want you to see. 566. It says a piece of metal is to be cut in the shape of a parallelogram. So parallelogram means that this bottom length A to D is actually the same as B to C up here. The length of AD and AC are 6.4 and 8.2. And the angle between A and B in the diagonal AC is 48. If the angle between side A and BC is obtuse, meaning it's bigger than 90, find the area of the parallelogram. Okay. So I drew what we have here. And we are going to write draw our picture so that we have that to work with. Okay, so hopefully you have your picture drawn. So let's just write some things that we know about. Oh, we call this B, C, and D. And so we know that the length here is 6.4. So we really know this right here. We know this triangle. We know side angle. Okay, so that we do know. So it's asking us really to find the area of the parallelogram. So the area of a parallelogram is equal to the height times the base. But so we would have to get a right triangle, a right angle here, or a right angle there. So we need to find this angle, which we could find because if this is a right triangle, but we need to find this additional angle. So we do need to find that angle there. So let's find angle C. So angle C, we're going to find after we find angle B. So we have sine of B over the length, which is 8.2, is equal to the sine of angle A, which is 48 degrees over 6.4. And that means sine of C would be equal to the length of C, but we don't know either of those right now. Okay, so to find B, we're going to have sine of B equals 8.2 times sine of 48 over 6.4. And so let's get out our calculator here. Okay, we have 8.2 times the sine of 48 divided by 6.4. And we get 0.9521 there. So sine B equals 0.9521. So using the inverse sine, so the inverse sine of that is going to give us 72.2 is the angle B. So 72.2. So that means angle C, angle C will be the equal 180 minus 72.2 minus 48. So angle C 80 angle C will be 59.8. So now we know, so the area is going to be this side here, this right angle times the base so I could have drawn it right here too. Times the height, the base times the height. So this would have been a right angle here. So this would have been, so my base is 64. So let's just go down here. So the area is base times height, and the base is 6.4. And the height is going to be the sine of, we need the angle of C and oh, but I need the full diagonal, so I do need this one right here. It's going to be the sine of my height, the sine of the, so before we fill in height, we can only find the height by, the height is the sine of angle C, which is 59.8
and the height over the diagonal. The hypotenuse is 8.2. So the height is equal to the sine of 59.8 times 8.2. So I can just put that down here, 8.2 times the sine of 59.8. So the area should be 6.4 times 8.2 times the sine of 59.8. So 45.36. And it was in centimeters, so it should be centimeters squared. So we had to create a right angle. And I had to use all of that diagonal. So to do that, I had to do my right angle outside, but it didn't matter because I had the whole length of the diagonal and I wanted that height, which is the sine nu of angle C. So once we found angle C, we could use that. So send me messages if you would like to see any more problems as you're working through these and using what you're knowing about the law of sines. And then catch me back for the video for 7.2, and we are going to use the law of cosines there.